Okay, so in this question, we're given a curve, y equals 12 root x minus x to the 3 over 2 minus 10. And we need to work out the coordinates of the turning point. So we'll be using differentiation for that. So part A, we have y equals 12, and the first thing is we are going to rewrite it in index notation. So the root x will become x to the half minus x to the 3 over 2 minus 10. And now we can differentiate this. So dy dx equals, so the half comes down, multiplies to 12, gives you a 6, and we minus 1 off the power, gives you a minus half, minus, so the 3 over 2 comes down, x, and 3 over 2 minus 1 is a half, and the minus 10 disappears. Okay, so to get the turning point, we need to set the derivative equal to 0. So let's set that to 0 and solve this equation. And to solve it, the best method is to rewrite this in surd form. Often index notation is better for integration and differentiation, but when you want to solve equations, it's better to have surd form. So the first one is 6 over root x minus 3 root x over 2, and that equals 0. And we'll bring this to the other side. So 6 root x equals 3 root x over 2. And now we can cross multiply. We'll multiply the 2 up over here to give us a 12. And the root x will multiply here to give us 3x overall. So therefore x is 4. So the x coordinate is 4, but they did ask us to get the coordinates, so we do need to get the y coordinate. So let's plug 4 back into the original equation. So y equals 12 root 4 minus 4 to the 3 over 2 minus 10, and we can work that out. Root 4 is a 2, so 2 times 12 is 24. Then we have 4 rooted, the over 2 is a root, so that gives you 2, and then to the power of 3 gives you 8. That's minus 8 minus 10. So that's overall equal to 6. So therefore the coordinates of the turning point should be 4, 6. So that's part A. Part B, we need to work out the second derivative. So we had the first derivative up to there. We can now differentiate that a second time. So part B, dy dx, d2y by dx squared equals, so the negative half comes down, multiplies to 6 to give us minus 3, and we minus 1 off a negative half gives us a negative 3 over 2. Minus, now this half will times the 3 over 2 to give us 3/4 x, and half minus 1 is negative half. So that's the second derivative, that's done. And part C, we want to find the nature of the turning point. So we found the turning point, 4, 6, but we're not sure if it's a max, that's a max, or if it's a minimum. And we're going to use the second derivative, so the method is that you substitute the x coordinate into the second derivative, and if it happens to be a positive answer, it means it was a negative, a minimum. So that was if it was positive, and if it was a negative, it's a maximum, a local max. So let's, part C, let's substitute 4 into here. So you get minus 3. This is a negative power, so that's over 4 to the 3 over 2 minus 3 over 4, that's 3/4, and then this is a negative power, so we're going to put that at the bottom. This is root x, so that's going to be root 4. And we can work this out. The bottom here, this is square root of 4 to 2 to the power of 3's and 8, so this is minus 3/8. Minus, and this is a 2, so 2 times 4 is 8, so that's another negative 3/8, and that's equal to minus 3/4, which is negative. Therefore, this turning point was a local max, so therefore it's a local maximum. Done.